So how did you go with question 1 and 2? Well, let's now do them together. We're being asked to convert the following angles to radian measure in terms of pi. So let's begin with our first one. We have 120 degrees and we need to turn that into radians. Well, to do that, we're going to times it by pi on 180. So that means I'm going to get 120 pi over 180. I need to give my answer in the simplest form, so I'm going to divide the top and bottom by 60. 120 divided by 60 is 2, and 180 divided by 60 is 3. So my answer to the first one is 2 pi over 3. Hopefully you got that one correct. Let's go to our next one. We have 455 degrees, and we're timesing it by pi over 180 in order to get it into radians. So what we're going to do is we're going to, let me just times it across first. So 455 pi over 180. Now I can divide the top and bottom by 5 to simplify it. So I know that 455 divided by 5, well, 5 goes into 45 9 times, and 5 goes into 5 once. So I'm going to get 91 pi. And on the bottom, 180 divided by 5 is 36. This can't be simplified anymore. So my answer is 91 pi over 36. Hopefully you did well in answering question 1. Let's now move on to question 2. Question 2. So here we have to convert the following angles to degree measure. So we're going to take 11 pi on 6 and turn it into degrees. To do that, we're going to times it by 180 over pi. We are able to cancel out our pi's, and I could also go, how many times does 6 go into 180? Well, 6 goes into 180 30 times. And you can think about it, 6 goes into 18 3 times, so 6 goes into 180 30 times. It's really not that tricky maths. Then 30 times 11 is 330 degrees. Don't forget that degree symbol. You won't get your full marks if you don't put it. Next, let's go 12 pi over 5. I want to turn it into degrees, so I'm going to times it by 180 over pi. Once I'm here, I can do some cancelling. This pi will go away, and I know that 5 goes into 180 36 times. 12 times 36 is 432 degrees. So these are my 2 answers for question 2. Could you now try question 3 for yourselves? Pause it here and try your best. So how did you go with question 3? Well, let's now try it together. So question 3 is saying, for the function this, state the, and A is finding the period. So how do we find the period? Well, the period, we find it by going 2 pi over whatever is in front of our x. So what's in front of our x here? Well, it doesn't initially look like there's anything in front of our x, but we know that this is just another way of writing 1 over 3x. So that means 1 over 3 is in front of my x, which means that it's going to be 2 pi over 1 over 3. Again, I'm confident that you'll all be able to answer this, but just for those who need a bit of a refresher, you're going to go stay, change, flip in order to answer this, and therefore you're timesing together your numerators, so it's just going to be 6 pi. So the period is going to be 6 pi. Next, let's answer what the amplitude is. Remember, the amplitude is just going to be the number out the front, but always remember that it's never going to be a negative number. So what you're doing is taking the absolute value of it, and it's going to be that. So it's not going to be -3, it's going to be 3. Lastly, we need to find what the range is. To find what the range is, sometimes it can be helpful to do a quick sketch of what we're doing. So let me bring this up. Let me bring this over here. So let me give a quick sketch of this graph. So it's not going to be entirely accurate, but we just need to figure out the range. So I know that it's shifted down -1, so it's going to be centered around -1, and I like putting in my pretend axis. So that's where it shifted down to my vertical translation. I then have an amplitude of 3, so that means it's going to go up 3, so 1, 2, 3. It's going to go up to 2, and it's going to go down 3. 1, 2, 3. So negative 1 minus 3 is going to be negative 4. So it's going to look something like that. Remembering that 1 period is 6 pi. I've been shifted down by negative 1, so it's going to look like that. And as you can see, my range is just my values of y, the range of my y values. So it's going to be from negative 4 to 2. So I'm going to grab my pen, and I'm going to say that my range is negative 4 to 2. So that is my range. Perfect. Hopefully you're able to do that correctly. Let's now move on to question 4, which is asking us to evaluate the exact values for the following. Give this a go and pause it, and then I'll see you soon. So how did you go with question 4? So let's now do them together. We've been asked to evaluate the exact values for the following. So the exact values. So let's begin with tan of 8 pi over 3. So when we encounter a problem like this, what we really want to do is break up this angle so that we have something plus an angle that we find in our first quadrant. So if I have tan of 8 pi on 3, I would break that down into 9 pi over 3 minus pi on 3. The reason why I would do that is because pi on 3 is an angle that I have in my first quadrant. We call these the reference angle. So now I could rewrite this as tan of 3 pi minus pi over 3. Now, once I'm here, how can I simplify this even more? Well, I know that 3 pi is simply 2 pi plus pi, to state something rather obvious. So let me now rewrite it again as tan of 2 pi plus pi minus pi over 3. Hopefully you can appreciate that this right here and this, they're the same. All I've done is broken up this 3 pi into 2 pi and pi. And the reason why I've done that is so you can appreciate the fact that if I were to have a unit circle, going 2 pi just takes me back to the beginning. Going 2 pi around simply takes me all the way back to the beginning. So I'm starting here and I'm going 2 pi around just like that. So in that case, I can really just ignore this 2 pi. I'm going to have tan of pi minus pi over 3. Now hopefully this is ringing some bells for you. You should know this as a part of your symmetry properties. We know that we know that tan of pi minus an angle is going to be negative tan of that angle. The reason why we know this is a true statement right here, let me highlight that in green. We know this to be true. And the reason why, actually that's kind of ugly, that's not highlighted in green. The reason why we know that this is a true statement is because we have pi over here. So if I'm going back by pi on 3, that's going to take me here. So I am in my second quadrant. Is tan positive or negative in my second quadrant? Well, you might remember cast. So my tan is positive in my fourth and my first, but it is not positive in my second. Therefore, tan is negative in the second. So that means I could rewrite this as tan of pi minus pi over 3 as simply negative tan of pi over 3. Now you just need to know what tan of pi over 3 is. So this is an angle in your first quadrant, and hopefully you're able to immediately recognize this as the square root of 3, which means that is my final answer, negative the square root of 3. Now I went through this question rather slowly, so not to get anyone confused, but hopefully in a test situation you would be able to do this far quicker. Let's now go through our next one. So let me put up some lines to separate us off. And let's now attempt the next one. The next one is going to borrow very similar logic. So I have 20 pi over 6, and what I want to do is break this up so that I have an angle plus an angle that I have in my first quadrant. So it's going to be cos of, and I'm going to break this up into 18 pi on 6 plus 2 pi on 6. That is going to be the same as cos of 18 goes into 6 3 times, or 6 goes into 18 3 times, plus pi on 3, because 2 over 6 is just 1/3. So that is what I'm left with. Now we're going to break up this 3 pi into 2 pi plus pi. Then I've got my pi on 3. We know that this 2 pi here is simply going to take me right around my unit circle. So let me again draw my unit circle. I'll draw it like this. I know that if I have 2 pi, it's simply going to take me right around to where I'm starting. So that means we can more or less just ignore it and rewrite this as cos of pi plus pi over 3. Now again, this is where we need to use our symmetry properties. We know that when we have cos of pi plus an angle, that is the same as negative cos of that angle. Now the reason why that is true is because if we were to think of pi plus theta, well, here is, let me get the blue back, here is pi. So if I'm going to plus theta to it, I'm going to end up in my third quadrant. Again, you might want to remember C, A, S, T. Cos is not positive in my third quadrant, it is negative in my third quadrant. Also, think of cos as your x values. So anything to the left of your y-axis is going to be negative cos, so your second and your third quadrant. So that means I'm going to get negative cos of theta. That means I could rewrite cos of pi plus pi over 3. That is simply going to equal negative cos of pi over 3. And hopefully you know that cos of pi over 3 is simply the same as negative, well, that negative because it's there, cos of pi on 3 is 1/2. So altogether it's going to be negative 1/2. Now I might just want to stop here for a second, and you might be thinking to yourself, how on earth are you figuring out what cos of pi on 3 is, or what tan of pi on 3 is? Well, I've memorized my first quadrant of the unit circle, and I think that is the most efficient way to do it. But of course, there are other ways you can do it. One way is to use your special triangles. So you should memorize how to draw your special triangle. So this is going to be 2, 1, the square root of 3. This right here will be pi over 3. And this will be pi over 6. This is a right angle triangle, a right angle. So now, if we were asked to find what cos of pi on 3 is, you'd simply find pi on 3 and say, well, that's adjacent, 1, over my hypotenuse, 2. So 1 over 2. Again, if we would come over here and we're asked to find what tan of pi over 3 is, I would come over here and I'd say, here's pi over 3. Tan is TOA, so opposite, square root of 3, over adjacent, 1. Square root of 3 over 1 is just the square root of 3. Alternatively, I would recommend you memorizing the first quadrant of your unit circle. I think this is a very efficient way as well. All right, so we've done the first 2 questions. Let's now move on to the next 2. So here we are. Let me rule up, I'll rule the line later. All right, so again, we're going to use the same technique of breaking this up into angles, which is an angle plus an angle, which is our first reference angle. I said an angle a lot of times in that sentence. But before we do that, let's deal with this negative. So what I'm going to do with this negative is take advantage of another symmetry law that we know. And this one has to do when we see a negative as our angle. So whenever we see a negative and a sign, we can take that negative simply out to the front. So I'm going to rewrite this as negative sine. Then I can break this up. So what am I going to break 19 pi over 4 into? Well, why not 20 pi over 4 minus pi over 4. That would be the same as negative sine of 20 pi over 4 is 5 pi minus pi on 4. Now, I'm going to break this up even more. I know that 5 pi is simply 4 pi plus pi. So I'm going to write this as negative sine of 4 pi plus pi minus pi over 4. Now, what is 4 pi? Well, if I was to think of my unit circle, let me draw it out. Here is my unit circle. 4 pi would be once around my circle, because that's 2 pi, then again around my circle. That would be 4 pi. So it's taking me back to where I started. So just like 2 pi, we can, in a sense, just ignore this 4 pi. We can take it out and it will still equal the same thing. So it's going to be negative sine of pi minus pi over 4. Now, again, we need to utilize our laws, symmetry properties. We know that sine of pi minus an angle is going to be equal to sine of that angle. Now, how do we know that? Because pi minus theta, so pi is here, and if I was to go back an angle, so pi on 4, for instance, is going to take me back here. I'm starting at pi, then I'm going back. It's taking me here, which brings me to my second quadrant. And because sine is positive in my second quadrant, that means I'm going to have a positive answer here. Think of sine as your y values, so anything above the x-axis is obviously going to be positive for sine. So that means I can come here and I can write out that negative sine, so don't forget that we still have this negative here from all the way back here, is going to be pi minus pi over 4, which is going to be equal to negative sine of that angle. Now this is where some of us may make a mistake. Obviously, it's going to be positive sine for when we have pi minus an angle, but remember we still have this negative here. So the negatives are not, I'm not going to get any cancelling out of negatives. That negative is going to stay. So now I need to figure out what sine of pi on 4 is, and that is going to be the square root of 2 on 2. So it's going to be negative of that. So that will be my answer. I really wish I could change the thickness of my pen to be thinner, but I cannot. There we go. Let's now answer the last one. So let me come here. Let me rule up my page. Try to answer this one. Hopefully you answered it before and you were able to do it successfully. The first thing I'm going to do is take note of the fact that I have a negative here, and I know that my rule for when I have cos of a negative an angle is I can just get rid of that negative. I don't even have to think about it. So it's just going to be the same as 14 pi over 3. I now am going to break that up into an angle plus an angle from my first quadrant. So what I'm going to do is break that up into 15 pi over 3 minus pi over 3. Now that we're here, let me keep working this way. That's going to be the same as cos of 5 pi minus pi over 3. Close it off. Let's now think of our unit circle. We know that if we have 5 pi, that's simply the same as 4 pi plus pi, because 4 pi plus pi is 5 pi, and then we are minusing pi over 3, which means if I have 4 pi, it is going around the circle once, that's 2 pi, and going around again, that's 4 pi, which is simply taking me back to where I started, which means we can, in a sense, get rid of this 4 pi. So this is going to be equal to cos of pi minus pi over 3. Now we need to remember our symmetry properties for pi minus an angle for cos. So what is cos of pi minus an angle? Well, it's going to be equal to negative cos of that angle. And the reason why we know that is because pi minus theta, where here is pi, so if I'm minusing an angle from it, it's going to take me over here. And that is obviously in my second quadrant, where cos is negative. Thinking of cos as my x value, so anything left of my y-axis is obviously going to give me a negative cos. So now I could come over here, I could rewrite this as negative cos of pi over 3. And again, if you're struggling to figure out what cos of pi over 3 is, you could refer to your special triangle. So we can come up here. I could go cos of pi on 3. Cos is adjacent over hypotenuse. So it's going to be adjacent hypotenuse 1 over 2. So I'm going to come down here and I'm going to write that this is, let me write it over here, is equal to 1 over 2. And don't forget your negative, it's going to be that. So those are going to be your answers for question 4. Again, I've taken it really slowly answering these questions. In a test scenario, hopefully you could move a little bit quicker than what I was doing there. But hopefully that all made sense for any of us struggling with this concept. Could you now give this question a go? And we'll do it together later. So pause the video and give this question a go. Alright, so hopefully you gave this question a good go. Let's now zoom in and do it together. Zoom, 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 zooming right in, and we're giving it a go together. So we're being told that if cos of x equals cos of pi on 6, and x is between 3 pi on 2 and 2 pi, we need to find the values of x. Before we even approach this question, let's draw ourselves a unit circle. Now that we have ourselves a unit circle, let's really try to ask ourselves what this question is asking of us. It's saying that cos of a certain angle is going to be equal to positive cos, remember there's a positive in front of here, of pi on 6. So what we're going to ask ourselves is, for which quadrant is cos going to be positive? And obviously we know it's going to be positive in my first quadrant, where I simply have an angle, theta, and it's also going to be positive. Cos is also going to be positive in my fourth quadrant. And we know that the general angle for my fourth quadrant is 2 pi minus theta. We know that because to go right around my unit circle is 2 pi. So obviously 2 pi minus a bit of an angle is going to bring us to our fourth quadrant. And this is where cos is positive. We know that cos corresponds to my x values. So it makes sense that it's positive here and here on the right-hand side of my y-axis. Here and here is where cos is positive because this is where my x's are positive. Perfect. Next, let's look at our domain. Our domain is saying that x exists between 3 pi over 2 and 2 pi. So here is 3 pi over 2 right here, and 2 pi I've already labeled. So it's telling us that our angle is going to exist between here and here, which excludes this angle right here. Of course, if it was to be my first quadrant, it would be pi on 6. It would be cos of pi on 6 equals cos of pi on 6. And what a boring statement that is. So they're limiting us to our fourth quadrant in order to find what our angle is going to be. So we know that x, this x right here, is going to be 2 pi minus theta. So let me write out that x is going to be equal to 2 pi minus an angle. I can now rewrite this right here. I can rewrite this with this knowledge of what x is. So it's going to be cos of 2 pi minus theta equals cos of theta. Now, do we know what theta is going to be? Well, we do. This rule is just rewriting this. So theta is obviously pi on 6. So I can now rewrite this. So this is going to be cos of pi on 6 because theta is pi on 6. And here's another pi on 6. Here's another theta, so I can put pi on 6 here. So it's going to be cos of 2 pi minus pi on 6. If I now simplify this, I will get my answer. So what will that be? Well, in order to subtract something like this, I need my denominators to be the same. So I'm going to change that 2 pi into 12 pi over 6 minus pi over 6, which is going to be equal to cos of pi over 6. 12 pi over 6 minus pi on 6, well, I'm just subtracting my numerators, is going to give me cos of 11 pi over 6, which is going to be equal to cos of pi on 6. So that means, if I was to come here, this right here is going to be my x value. Cos of 11 pi on 6 is going to equal to cos of pi on 6. So I could come here, I could say, therefore, x is going to be equal to, that's an ugly x, let me try again. X, that's a beautiful x, is 11 pi on 6. That is your answer. Actually, let me do it in yellow. All right. Before we move on, I just want to make sure that everyone understands what we've done here. What have we done? What does this even mean? Well, let us come over here and draw in some lines. Let me begin by putting in pi on 6. We know that pi on 6 is here to here, which means I come here, here. This angle right here, the one I'm drawing in, that angle is pi on 6, that angle. I can't draw it in, it's too small. So that means this value right here, my exact values, which correspond to pi on 6, hopefully we've all memorized the first quadrant of our unit circle, is going to be the square root of 3 over 2 and a half. So if I'm looking for cos of pi on 6, I know that cos is my x values, so it's going to be my x value. So cos of pi on 6 is going to be equal to the square root of 3 on 2. So let me come over here and say that this would be this. Next, let me say, well, what is cos of 11 pi on 6? Well, we know that 11 pi on 6, if this is our reference angle, we're just going to our fourth quadrant. I'm going to come over here. I'm going to grab that. I'm going to come here. It's just going to be down. Whoa, I thought I was something else. It's just going to be down here. And it's now going to be, let me do it in green. It's just going to be that angle. So that's going to be 11 pi on 6. It's going to take me down here. What are my exact values for this point? Well, it's going to be the square root of 3 on 2 and negative a half. So cos of 11 pi on 6, there's 11 pi on 6. Cos is my x values, so it's going to be this. Cos of 11 pi on 6 is the square root of 3 on 2. So I come over here and I'm going to write that this is the square root of 3 on 2. And hey presto, look, the square root of 3 on 2 equals the square root of 3 on 2. That's a true statement, which means that x is equal to 11 pi on 6. Hopefully this enables you to understand what we're doing when answering these types of questions. Hopefully you got that correct. Could you now give this question a go? This question is kind of hairy. Good luck. So how did you go with this question? It's a little tricky, isn't it? So don't be too disappointed if you weren't able to get the answer. Let's now take it really slow and try to figure it out together. So let's read it. If cos of x equals negative cos of 3 pi over 11, and negative 3 pi on 2 is less than x is less than pi. Find the values of x. It's quite a mouthful. Now, this question is similar to what we previously did in our last question, but I'm going to approach it in a slightly different way, but utilizing the same principles. So let's begin by taking it really slow, because I fear that some of us might not even understand what this type of question is asking. So let's begin by just looking here at cos of 3 pi over 11. Now, we haven't memorized what cos of 3 pi over 11 is. 3 pi over 11 isn't an angle that is pi on 4 or pi on 6 or pi on 3, one of the ones that we've memorized. It's just kind of a random angle that's in my first quadrant. So let's just draw it in. So let me come over here and draw it in. I might have to first do that. Let me use red, and I'm just going to draw it in. There it is. Now, we haven't memorized this angle, so that means we're not going to know what my exact values are going to be. So let's just call them A and B. So if I'm being asked to find cos of 3 pi over 11, well, I know that my cos is just my x value, so it's simply going to be A. So this is going to be A. But it's very important that we see this negative. What we're trying to find is cos of x equals negative A. So it's actually, if this value down here, that's A right there. So obviously negative A is going to be symmetrical to it. It's just going to be over here. So over here, that's going to be negative A. And obviously, I say obviously, but we could keep on drawing down and get to this point as well on my unit circle. So we could say that this point is going to be negative A, and that negative A is what I'm after. Negative A, B, and down here it's going to be negative A, negative B. But we don't care about this negative B, we just care about these negative A's. That's what we're after. So let me come over here and let me draw in some lines from here to here, and draw in another line from here to here. Perfect. Now, would you all agree with me? Because these are symmetrical, this angle right here is simply going to be 3 pi over 11. 3 pi over 11. So too, this down here is also going to be 3 pi over 11. Because if it's all symmetrical, this has to be 3 pi over 11. This one down here has to be 3 pi over 11. I'm now going to get rid of this. We don't really care about this. We're going to get rid of it. It served its purpose. Thank you very much. But now we bid you adieu. Let's get rid of it. There we go. So now, and I could rewrite this like this. Cos of what angle is going to give me negative A? Now, I fear that many of us would go, that's easy. It's going to be here to here, and also here to here. This angle takes me here to get me my negative A, and this angle goes all the way down here to get me my negative A. Bada boom, bada bing, I'm done. But let's not rush ahead of ourselves. Let's get rid of these lines. Let's now keep in consideration our domain. Now our domain looks kind of funky, so I'm going to write it in a slightly different way. I'm going to write it, it's going to be the same, I'm just going to write it a little bit differently. I'm going to say my x is an element of, and I'm going to use some pretty colors, I'm going to say negative 3 pi 2 to 0, close it, bang, let's go blue, then 0 to pi. Now this and this, it's the same thing. I've just written it in a bit of a different way because I think it's going to help us. So let me now show you where this domain exists. Just this first part here, this is 0 to pi. It's going to be from 0 to pi. No big surprises there. So it's going to be here. Let me do a big one. It's going to be here all the way to here. So that means now when I'm finding what my angle is going to be, I was correct when I said it was going to be from here to here. That's absolutely correct. It's going to be from here to here. So what's that going to be? Well, that means my x is going to be equal to, well, if I know that from here to here, to make a full from there to there, that's pi, 180, from there to there. But now I'm minusing this 3 pi on 11. I'm going back. So it's like I'm going pi minus 3 pi on 11. And I just need to, that x is just so ugly. I need to kill it and redraw it. That's a bit better. So if I want to find what my x will be to get me negative a, I just need to figure out what this angle is. And it's obviously going to be pi minus 3 pi on 11. So I could rewrite this as 11 pi over 11 minus 3 pi over 11. And that's going to be equal to 8 pi over 11. And guess what? That is one of my solutions. We're doing it. We're nearly there. Now, let me rub that out. Mission accomplished for the first one. But now I fear that many of us would just go whoop, 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 whoop. There's my second one. But look, this angle goes outside of my domain. Does everyone see how this orange line is going to be bigger than pi? And I can't have anything bigger than pi. So I am not going to find that one. It's not going to exist. So that means I'm going to have to look at my second section of my domain. So this one right here. Now, we're going to be going backwards. So we're going to be working clockwise. So just think of it as opposite as before. So now this right here, that's going to be negative 3 pi on 2. So it's going to be all the way, all the way, all the way, all the way here. That's what it's going to look like. So this is where my angles can exist for the second part of my domain. So that means, let me get my orange back, I could have an angle from here working backwards to here. And if I do that, I'm going to go, I'm going to get to my exact value of negative a. So I just need to figure out what this is going to be. And hopefully you can see that from here to here would be negative pi. So from this point all the way to this point, that's negative pi. But then I'm going back a bit. So in this case, when I go back, I'm going to be plusing 3 pi on 11. So my second x value, noticing I'm going to have more than one values, is going to be negative pi plus, oh, that's an ugly pi. Let me try again. Negative pi plus 3 pi on 11, which is going to be equal to negative 11 pi over 11 plus 3 pi over 11, which is going to be equal to negative 8 pi on 11. And when you really think about it, that makes perfect sense, because if here to here was 8 pi, then here to here is going to be negative 8 pi on 11. Sorry, if here to here is 8 pi on 11, then here to here is going to be negative 8 pi on 11. I have to be ever so careful in how I speak. There we go. So that is going to be my other one. Perfect. Perfect, perfect, perfect. Let me rub that out. Is there another one I could find? Absolutely there is. What about the angle starting here and going all the way to here? That's going to take me to negative a as well. This from here to here is going to take me to negative a, and that's what I'm after. So how am I going to find that? Well, in this case, from here to here, that's going to be negative pi. From here to here is going to be negative pi. And then I'm going to be minusing negative 3 pi on 11. Negative 3 pi on 11. So that means my third x value is going to be negative pi minus 3 pi on 11, which is going to be equal to negative 11 pi on 11 minus 3 pi on 11, which is going to be equal to negative 14 pi on 11. That is going to be my third x value. And now I am done. I have answered this question. I've taken this question ever so slowly to make sure that you've gotten it. I apologize if I accidentally said the wrong word here or there when I was explaining it. It's kind of all a bit of a mouthful. But these values, 8 pi on 11, all of them are going to give me this negative a. And I just want to prove this to you a bit more. So if you're saying, I get it now, Mr. S, you don't need to explain it anymore, you can click off, but I just want to really hammer home this point. Let me come over here. Let me bring up this. Here is my unit circle. Let me zoom in a bit less. Whoop. All right. I'm going to start with 3 pi on 11. I'm going to put in 3 pi on 11. And can we all see? So this is where we started from. We said 3 pi on 11 was A. So as you can see, it's negative 0.655. So we come over here. Do you remember when we did this at the very beginning? We drew in a line. Let me just do this rough now. We drew in a line from here to here. And we said that was 3 pi on 11. And we said it was A and B. Well, it turns out that A is negative 0.655. And we said this was 3 pi on 11. So that's what we've just done now. But we wanted to find when this was negative. So what we're saying is we're going to get negative 0.655. So let me say that again. We're going to get negative 0.655 when we have 8 pi on 11. So let's test that out. What if I have 8 pi on 11? It's going to take me over here, and my cos is going to be negative 0.655. That's exactly what we found. Now, what if we put in negative 8 pi on 11? So I come over here, I put in a negative, I come here, look at that, negative 0.655. What about negative 14 pi on 11? I come over here, I type in 14, it's going to take me over here, negative 0.655. So these are the three values which are going to give me my negative cos of 3 pi on 11 and also fall within my domain. I really hope that this was a clear explanation of this type of question. If you do have any issues with it, try rewatching this again, or if it isn't clear enough, come speak to me and we can sort it out. Well, actually, we won't be able to speak to each other, but just give me an email. Maybe I'll make another video like this if you found this one kind of helpful. Let's end this lesson here, which means in the next lesson, I will go through the remainder of this test. See you then.